project in EC35 is to create an AM radio receiver. There are a lot of possible circuits for this project, but we chose to use the super heterodyne. The objective of this project is to produce a functioning AM receiver that receives AM broadcast signals and transmits it clearly to the speaker.
For this project, we use different kinds of resistors, transistors, and capacitors. But more importantly, we use one volume control, one polyvariable condenser, one ferrite antenna bar, one antenna coil, one IF transformer, one oscillator coil, two antenna bar stand, one printed circuit board, one silicon diode, and one set screw.
I'm here to discuss the block diagram for the super heterodyne receiver. Now, an AM stations transmit between the frequency of 525 kHz to 1625 kHz, and it usually has a bandwidth of 10 kHz. And so, let's discuss the block diagram for the super heterodyne receiver. And as we can see, after the antenna, it is then fed to the RF amplifier, which amplifies the signal. Since after it is transmitted, it loses a lot of power. It is then fed to the mixer, where basically what a mixer does is it just adds and subtracts the frequencies between the RF amplifier and the local oscillator. After that, it is fed to the filter, where it is tuned so that we are only getting the frequencies that we want. And then it is fed to the IF amplifier, where the intermediate frequencies is amplified. After that, we feed it to the demodulator. For AM, it is usually the AM envelope detector, so that we can reverse the process of modulation, and we can retrieve the original information. And then we feed it to the audio amplifier and then to the speaker, and we get the sound.
So we based our circuit board design from a from a circuit we found on the internet, but slightly modified it to prevent any components from being electrically shorted.
Let's discuss the design and calculations of our project. Okay. Since at the reception we must tune our receiver to a certain frequency, but for simplicity's sake, let's assume that we are receiving 1000 kilohertz AM signal. So as we receive it at the RF filter, it is then fed to the RF amplifier, so to amplify the signal. After that, it is then fed to the mixer, where it is mixed with the VCO high oscillator at 1455 kilohertz. As you can see, the mixer will produce frequencies of 2455 kilohertz, 1455 kilohertz, and 455 kilohertz. After this, we feed these frequencies to an IF filter, so that only the 455 kilohertz will remain. We then use an demodulator, which is being fed by a VCO low oscillator at 452 kilohertz. We just add and subtract these frequencies, so the output would be 907 kilohertz, 452 kilohertz, and 3 kilohertz. And then we add an audio filter, so that only the 3 kilohertz signal, which is the typical human voice or the human sound frequencies that people can hear. And that's the end of our calculations.
Thanks. So here we see our modified printed circuit board. Now, as I adjust the volume and the RF oscillator, and each of the IF filters. We can hear very, very little noise, like popping sounds coming out of the speaker. But all the same, it's still noise. So one possible troubleshoot for that is, because of our transistors, is not the recommended transistors for this type of circuit, but we acquired the closest thing to the specific transistors, but it may cause some non-linearity in receiving the signals, therefore allowing the noise only to propagate in the speaker. Also, with the addition of the wires coming out of the IF filters, these are susceptible to additional noise noise signals, and therefore adds to the noise we get from the speaker. In conclusion to this project, our modified circuit unfortunately did not function as an AM receiver as it should have been. But nonetheless, the lessons from the lectures and lab have been fully applied during the construction,